At a certain time of night around here, things get spooky. This week's videos are going to put a bit more vocabulary on something we've already been doing all semester. I've kind of tricked you into doing it. It's called Object-Oriented Programming, or OOP. And we've seen this in the past few weeks, especially when we've been doing things like modifying lists or modifying strings or adding keys to dictionaries. The basic principle of OOP is that anything we create in a program is an object that has a state, and we can do things to it, but also we can do things with objects. This week's going to focus mostly on the doing things with objects, though of course we're going to be incorporating things that we already know. We're also going to be looking at modules, and in fact two, one called JSON and another called random. So all that's a bunch of technical jibber jabber unless we actually have examples. So what have we been doing that is already classified as object-oriented programming? Well, let's take our cat names list as one example. If I put it up here on my screen, it now exists. It didn't exist before that, so now it actually has a state. And a state is essentially just a snapshot of what the object is at any given time and all its properties. Here, we have a list that actually exists. It has 4 items. And if I were to append to it, I'm changing the state. I'm actually operating on it. That's the object-oriented part. We're focusing around the fact that this thing is called cat names, and that is the actual object that we have made. Again, anything we make in our programs, that's an object. We made this object. We added something to it. We changed its state. It now has 5 items. So if we take a snapshot, again, a state is just a snapshot of a given object at any given point in time. If we take a snapshot of it right now, it has more items than it used to. If we remove 2 items, that changes its state yet again. It changes its state each time we remove an item. And we know we're operating on this particular object because we're using those dot operators. We're using operators to change the value of what this object actually contains. And that's essentially, again, just what a state is. At any given moment, our list contains any number of values. It evaluates out to a certain length. It has certain values inside it that we can grab. And that's true of pretty much all of our objects. For example, a variable that contains an integer at that moment has the state of being that value. If we add to it, we are changing the state of that object specifically. So again, all we're thinking about is the ways that we can operate on, and that's why we've been using the word operator when we've been talking about the dot, the single equals. We're using operators to change the values or states of something over the time of our program. And I've also been throwing the word module around a lot and said, oh, we'll get to that later. Well, later is now. Modules are things that we bring into programs to supplement what we can do. They give us more powers to use. So far in the semester, we've gone halfway through the semester without needing them. We've already seen that Python is pretty powerful. We've been using batteries included Python. You might have heard me call it that a few times. We have things like integers, floats, strings, lists, dictionaries, all that stuff what I will call for free. And in fact, if we didn't get that as part of the bundled language, the language would be a little useless. Even with only half of those features, we wouldn't be able to do some of the labs that we have done so far this semester, so it'd be kind of hard to use. JSON is something that we don't need all the time. We haven't used it to this point, but now that we know how to use data structures, it's actually pretty handy for us. So in the rest of this video, we're going to see how to bring it into a program, and we're going to use it. One more note about this sequence of videos. I know you're saying, Lumen, just give me the code. We'll get there. We're going to be programming the same program over the course of the next few videos, piece by piece, part by part. I've given you a sandbox.py file in your sandbox folder, and I've given you a couple of other things in the data folder so that you can do it piece by piece with me. In this video, we're going to work on bringing in JSON, using it to open some files, look at what we get, and then we're going to call it a day. So let's get started. Now, before we go any further, it might help us to know exactly what we're doing. Well, I call this program the Monster Mash because what we're going to be doing is loading some descriptions, some monster types, and then creating random monsters that we should find canny, unique, fun as we approach the Halloween holiday. So where are we going to get that data from? Because I don't see anything here. Well, if you open up your File Explorer, you'll notice a data directory in your sandbox folder. I'll click into mine. And I see I have 2 files here, descriptions.json and monsters.json. I'm going to pop open descriptions.json just to take a look at it. And if I look at it, I notice that it looks a lot like a dictionary. It seems like it talks like a dictionary, but it is not yet a dictionary. This is actually in a file. It is a string. But what the JSON module allows us to do is load this in as if it were a dictionary and make it a dictionary. So we can already see what we might need to do to get one of the descriptions from this particular file. We notice we have a couple of keys. We have description and descriptions. Descriptions, of course, looks like a list that contains a number of descriptors that we can use to describe our monsters. So as we load this in, we might be thinking, how do we use this to get this item from a dictionary? What might we have to subscript to actually call up this list? So as you might have noticed, and as you heard when I was describing this particular program, there are two files that I'm going to load. So I'm going to do the load file dance twice. And because I'm going to do something multiple times, that strikes me as possibly a good candidate for a function. So we're going to see the instructions that we need to add, but it seems right that if we're going to do it multiple times that we should functionalize it. So I'm going to do just that. I'm going to head up north of my main function and start with my def keyword. Again, def keyword defines the beginning of a function. Call it load file, give it one parameter called file name, and it looks a lot like the election lab load function, which it's pretty much the same with one instruction added. So that parameter is going to allow us to pass whatever file path we want to use up to load file. Before we actually pass it to JSON, though, we actually have to point the system at the file. We have to do an open on the file in order for us to be able to send it to JSON. So if I say fh equals open, and I'm going to use my variable here, file name, so that no matter what I pass this function, it's going to open it. I'm going to use my R mode because I'm just reading it, not writing it. I'm not appending it, not deleting it. I'm just going to read the contents. And then I'm going to use my JSON because, as we know, this loads a file in as a string. It's not quite a dictionary yet. I'm going to use my JSON as a kind of translator or interpreter to take the contents of this file and make them a dictionary. And to do that, I'm going to say data gets the value of. So JSON will produce something. I need to get the value of it. JSON.load, and I'm going to load the FH or the file handle. So it's going to load that file, read the text, turn it into whatever appropriate data structure is there according to JSON format, and then we can send it back. We can say return data. Again, this function is going to be useful because we're going to be doing this more than once. And so I made my function just to load a file, throw it to the JSON module, have it translate, and then send the data back. And now that I have my handy, reusable, recyclable function, I can use it. So I'm going to use it to get some descriptions. So I'm going to say descriptions equals, and I'm going to load the file. And I am currently, if I look where my sandbox.py file is, I'm in this directory, but my neighbor directory is data. So I can grab from the data directory the descriptions.json file. If I do so, I'm actually going to see if what I got was what I thought I was going to get. So I'm actually going to print descriptions, save my program, and I'm going to run over to my terminal here. And I'm going to go to my sandbox folder where I make my videos. And I'm going to Python sandbox.py. If I did everything correctly, I should be able to see that I've loaded in all of the content that I saw when I looked at the descriptions.json file. So let's have a look at what we got. And it looks like we did. We got a bunch of stuff, and it looks like it's in a dictionary because we see that curly brace that ends it, a bracket that has the list there, the keys that we wanted to get here. Okay, great. To prove it to ourselves even more, do you remember what the name of the key was that we needed to grab in order to get that list? It was kind of confusing because it's also called descriptions. So just to note, JSON files are not basically all the same. They contain different keys, they contain different data depending on what they actually hold. As we're going to see when we look at monsters, they can be more or less detailed. We're going to look for the descriptions key because that was in the actual file. Save it. I'm going to go ahead and try to print it again and see what I get. And if I scroll up, I only get this time the list. So it has turned into a dictionary. JSON did that translation for us, and we're actually able to see the outcome of our process. And as mentioned, we have another file we're going to need to load. Now, I said that JSON files aren't structured the same way. They have some of the same rules. They still use that dictionary-like syntax, but they can contain really any number of keys, and those keys can contain any number of legal values. Here we have one additional key, and our name for the key that has our monster types in it is different. It's actually names, so it's not as confusing as description, plural, singular, doesn't matter. It could be anything. It can be arbitrary, just like a variable name. So files are going to be structured just a little bit differently. Anytime I give you a file, you are encouraged to, more than welcome to, probably should, scratch that, you should, open the file to look at it to see what I am giving you and how you might use it. Here, if we didn't open the file, it'd be kind of hard to know exactly what keys we were looking for, though we could print it out in our program to see, but sometimes these things are pretty long, so it could get kind of hard. So going back to the file as an text or a source, is probably the advisable method here. So I'm going to throw some details up on the screen, and I'm going to challenge you to complete the next line. And if this is what you did, great. One thing I'm going to do to set up for my next video is I'm going to pull those lists out into a separate variable. And so I'm going to drop down to the next line here and say descriptions actually equals descriptions, that key that contains all of the various descriptive terms that I want to use for my monsters. And I'm going to say monsters equals monsters and names being the key that we use to get all of the different types of monster. If I've done this correctly, I should be able to print descriptions, print monsters, and see that I've gotten exactly what I was hoping I would get. So let's cross our fingers and hope we got it. And it looks like we did. There's a lot of stuff that appeared behind me there. Both of those things are lists. They are the descriptors that I'm going to use to describe my monster and the names of the monsters that I'm going to use to make my monster mash. If it seemed like this video was highly conceptual and there wasn't a lot of practical work here, I can give you that. But we did learn a few things that were pretty important for at least understanding or contextualizing the work we do. The first thing we learned about object-oriented programming, and that it's programming in which we essentially do things to objects or with objects. In this video, we saw how to bring in the JSON object via an import. So that's a module. We learned about modules as well. So we imported JSON, and we learned how we can work with files that are what are called structured data in order to give our programs just a little bit more power and a little bit more organization. The next video, we're going to learn how to do the choice via the random module, and we're going to write another function of the monster mash.